Now in part B then, what we need to do is to find the tension then in the string on the particle P. So we need to do this by marking in the forces then that are acting on P. Well, there'll be the weight of P. It's got a mass of 0.5 kilograms, so the weight would be 0.5 g newtons. And there'll be a tension acting in the string acting upwards, which I'll call T, and that'll be T newtons. And we mustn't forget that the particle is accelerating downwards, so I'll mark that in. We discovered from part A that it was 2.8 meters per second. So mark that acceleration in there. So in order to find the tension, what I've got to do is look at the equation of motion for particle P. Now it's clearly moving downwards, and so what I'm going to do is resolve in the downwards direction, taking downwards as positive. So that means I'm applying the equation of motion F equals ma on P. So I'm looking at the resultant force acting on P downwards, so that would be 0.5 g, so mark that in, 0.5 g newtons acting downwards, minus the force in the string, the T value, T newtons, so it's minus T. This is the overall force then acting on P, and that's equal to the mass, 0.5, times the acceleration, which is 2.8. So all I need to do now is rearrange this equation to make T the subject, so I can add T to both sides and subtract 0.5 times 2.8 from both sides. 0.5 times 2.8 is 1.4, so rearranging this then we have T equals 0.5 g minus 1.4, and then just using a calculator work that out and you get 3.5. 3.5, don't forget the units, newtons, okay? The tension then in P is 3.5 newtons. That brings us to the end now of part B.